I'm Mamadou Coulibaly from Mali. So I'm going to talk about the status of insecticide resistance in Aedes mosquitoes in the African region. Even if it says Aedes mosquitoes, I'm just going to focus on two species, albopictus and aegyti. Please allow me to just pay tribute before I start to one of the scientists who touched my scientific life. Some of you might know him, Professor Yaya Touré, who served at WHO for 13 years. He brought me here in addition to WIN, the WIN network. So thank you to WIN for bringing me here, and thank you to Yaya for bringing me to WIN. So this is just the plan, and you've seen this, this map before, so this is just to show the distribution of Aedes aegypti in the African region, and also in the albopictus in the African region. And you can see that aegypti is more abundant than albopictus. Though we have some reporting coming on albopictus in the areas. This year, there was a report on albopictus being found in Mali. So what do we know about insecticide resistance in the African region? I have to say that I really found very few studies, so few that I could afford to cite them country by country. So you can see here we have the Cameroon and Gabon, and we have Aedes aegypti being resistant to DDT, but susceptible to BTI, Temephos, phenithrothion, and propoxyr. And as far as albopictus is concerned, it's resistant to DDT, but susceptible to deltamethrin, resistant to DDT and deltamethrin, and susceptible to BTI, Temephos, phenithrothion, and propoxyr in Gabon. So you can see the geographical distribution here of the resistance. And here in Gabon, we only have DDT resistance. Another study in Cabo Verde on Aedes aegypti shown to be susceptible to BTI and diflubenzuron, but resistant to deltamethrin and cypermethrin and Temephos. As far as the mechanism go, so there was a GST increase by 25%, MFO by 18%, alpha esterases by 19%, beta esterases by 17%. There was no target mutation detected in this study. In Senegal, we have Sil aegypti, resistant to DDT but susceptible to permethrin and phenithrothion. They also found a reduced susceptibility to deltamethrin, to lambda-cyhalothrin, and propoxyr, even if they believe that for propoxyr, more studies are needed because they are not confident of the study. The table is not here for you to read because it's too small, but it's just the result of that I summarized here. They also found that, so this is in Senegal. In Capo Verde, the study showed that Aedes aegypti was susceptible to permethrin, deltamethrin, lambda-cyhalothrin, phenithrothion, but resistant to DDT and propoxyr. Again, this is to be really confirmed, as I said. In the Ivory Coast, I came across two studies. One of them showed Aedes aegypti susceptible to permethrin, and the second one showed again Aedes aegypti susceptible to deltamethrin, permethrin, and lambda-cyhalothrin, and then they're also susceptible to propoxyr in Kumasi. Actually, this is resistant to propoxyr in Kumasi, as you can see here in the figure. Here you have propoxyr, and we have reduced mortality, lower than 80%. This is a typo. It should say resistance. I'm sorry about that. In Nigeria, this is an interesting study. They found aegypti susceptible to permethrin, but resistant to deltamethrin and DDT. And they also worked in different settings, farming areas and non-farming areas. And they came to say, to conclude that resistance is in both areas and that other factors outside agriculture may play a role in insecticide resistance. I found this to be very interesting for our next steps in WIN. In Ghana, they showed that aegyti was resistant to DDT and permethrin, and they went ahead and looked at the molecular mutations, and they found F1534C in aegyti, so that they looked within aegyti, and Formosus, and they found the mutation F1534C in both of them, and they also found the mutation V1016I. And here you can see the picture, the resistance levels in different sites in Ghana in 2014. This is a study that was done in over 2 years, 2013 and 2014, but when you look at the resistance level, you don't see a significant difference. So I also want to show this map. Is just, a provocative idea for WIN to probably produce the same kind of data we have as for Anopheles gambiae. And if you have data, we can have a map of the insecticide resistance. But for now, this is what I could show. And you have a resistance shown in these different countries. And these are the papers that I found published. And I'm aware that there are also data that are not unpublished. If WIN can help, please, this can be a very good opportunity to have the IR mapper for insecticide resistance in Aedes. What are the different mechanisms that I came across? GST, esterases, MFOs, and point mutations. And what are the insecticides, the classes that I came across that Aedes were resistant to? You can see the 4 classes, the 4 classical classes are here already, with just the few studies that were done. Different methods were used for adults. For adults, the F1s were used mostly. And WHO guidelines in 1908 and 2006 were used for adults. For larvae, the guidelines for 1981 and 2005 were used, and some of the papers used insecticide resistance ratios. And for the point mutation, DNA sequencing was used. In summary, I would say that more focus on aegyti as opposed to albopictus was seen across the studies. That may be due to the climatic condition not very favorable to the latter. And in general, there's less attention paid to Aedes in general, and a few insecticide resistance studies have been conducted in Aedes in Africa. So we'll come back to the basket of Dr. Rahman. And also the majority of the studies that were conducted treated the phenotypic assays, though a few analyzed metabolic and molecular testing. Different guidelines were used to conduct the assays, hence a need of harmonization of the assays. The majority of the studies were transversal surveys as opposed to longitudinal monitoring and or surveillance. And the same old tools for detecting insecticide were used. So this also called for some actions. As perspectives, I think we need more investigation at the global level and at the regional level, where I will also do some advocacy for WIN Africa in the African region, if we can have we can open the basket. And also, this calls for monitoring and surveillance in the areas, harmonization of existing tools for detecting insecticide resistance. There is need for developing new tools to detect resistance level and mechanisms so that that so far escape existing tools. Beyond insecticide resistance, I think we also need some studies on bioecology and the control strategies for Aedes species in the African region, where arboviral diseases are being progressively reported, though very timid. So this is what I wanted to share with you today. I thank the organizer and thank you for your attention.